Well, good afternoon, everybody. My name is Nate Schutta. I work at Pivotal. The best way to describe me these days is architect as a service, which I thought was a compliment the first time somebody called me that, and then I actually sounded the acronym out in my head and realized it might not have been meant as the positive that I was trying to take it as. But I spent the last several years trying to get my head wrapped around this whole cloud thing. You know, what does that mean? Because there's a lot of different options, and the cloud means different things to different people. You know, I like that adage, if you bring 20 engineers in a room and ask them to define cloud, you're probably going to get at least 20 different answers. But for some folks, when we talk about cloud, they think about microservices. And for other folks, it's all about modular monoliths. And for yet more people, it's all about containerless. And of course, for some of us now, we're thinking about serverless, because that sounds great. There's no servers. Now, of course, pro tip, there actually are servers. This stuff doesn't run on unicorns, at least not yet. And so a lot of people are very excited about that. And of course, that's before we even get into should we be in the public cloud, should we be on-prem, and which public cloud provider should we consider using, and how do we make sense of all that? Because that's what we have to do. We've got to juggle all these options and come up with the right solutions for the problems that are in front of us. And there are no simple answers in this space. I taught a graduate school class this past spring on the cloud, and one of the things I was really trying to get my grad students to internalize was you have to do the due diligence on these things. You've got to look through the pros and the cons and understand that for different workloads, there's going to be different options that make sense. So we'll start at the base level, which is IaaS. Now, I know this has sort of gone out of favor. We don't generally need to use this, although I did make my grad students do it just kind of on principle, frankly. But it's fascinating to me to see how infrastructure has changed over the course of my career. There's been this massive, massive shift. When I first started in software, servers were literally a homegrown thing. I mean, we ordered the chips, we put the chips into the motherboard. These are very bespoke, artisanal things. You would put lots and lots of effort into them. Now, I'll be honest with you, I love bespoke, artisanal coffee. I'm not so sure that's what I want in my infrastructure. And so after spending countless hours, days, weeks handcrafting these things, we would treat them, very, very personal because we put so much energy into them. And of course, if you were on the other side of this infrastructure game and you went to your infrastructure people and said, I need a new server, it could take weeks, or in some cases months, to get a new server instance spun up. I always like to ask people what their longest request to ready experience was, and most people will say like 3 months, and then you'll get somebody say, haha, it took me 6 months, and occasionally you run into somebody that'll say, oh, we had one take 9 months. We actually had one request that took a full year to come to completion. We had asked for a development database, a small little database to house some architectural artifacts, and it took a year. It didn't need to be sharded, it didn't need to be HA, it didn't need to be any of that fancy stuff, it just needed to hold a few artifacts. And I presume that as part of that project, they clearly must have built a database, right? I mean, that's the only thing in my head I can consider that how could it take a year to do that? Now, of course, if you think back to what it was like to do a project in this era in software, we had to answer an awful lot of questions very early in the process, often when we knew the least. So a very typical question would be, so how much capacity do you need for this fancy, smancy new app of yours? The only legitimate answer we could typically give was, I have no idea. And so what would we do? We'd have to swag something together. We'd take kind of our worst case scenario and we would double it, and then we'd maybe add a little bit more on top of that. And maybe we'd double it again just because it was in our best interest to have extra capacity and not need it than to need extra capacity and have to come back and ask for it later. Now, this, of course, meant we often were stuck with single-digit server utilizations, which was fine, except that meant lots and lots of expense going to our customers that they weren't getting the value for. And so you think about the lead time on these things, you think about all the tickets. This is one thing I do not miss about enterprise IT. I don't think I've ever managed to get a ticket right the first time. I don't know who creates these ticketing systems. I don't know on what planet these things are designed, but they clearly are not meant for us to actually successfully complete them. The best success I've ever had is you take someone else's ticket that worked somehow magically, and you copy it and then tweak the bits that need to change, and then fingers crossed. If you're really lucky, you know where these tickets are going to, and you can talk to those people directly, and then maybe things get done. And of course, he'd have to go to a bunch of meetings, and he'd have to exchange a bunch of email, and there'd be more meetings and more email, and it was just not a lot of fun. Now, in this era, these servers were such a personal thing for us that we often gave them very pithy names. I was at one company where all our servers were named after Simpsons characters. Thought that was kind of interesting. A friend of mine told me that their standard for a while was Marvel characters. So, who's your favorite Avenger kind of stuff. And of course, in this era of software, because we spent so much time and energy on these servers, quite frankly, we treated them like pets. So these are my pets. This is Han and Chewie. And they're basically members of the family. Let's be honest. That's what pets are. Someone, as an icebreaker several years ago, said, what animal would you like to be if you could be any animal in the world? And so you got some pretty interesting answers. Someone said, I'd be an eagle so I could fly. And someone said, well, can it be a mythical animal? Sure. I'd be a unicorn because that looks cool. I said, I want to come back as a house cat. And somebody just looked at me and said, a house cat? I said, yeah, think about their life. They sleep like 20 hours a day. When they want attention, they go get it. When they're done, they walk away. They have no natural predators. They've got lots of food. This seems like a pretty good gig. Now, Han and Chewie are members of the family. If they were to develop so much as a sniffle, I know that my family would entice me to spend virtually limitless money to make them feel better. And we would do that to our servers. We'd do whatever it took to keep them happy and healthy. And of course, one of the other really interesting constraints that we ran into was the fact that servers were this very constrained resource. They were very, very expensive. There were these proprietary things with proprietary operating systems. And so our CFO type people were like, hey, we got to get our money's worth out of this. And that's why we had this app server thing back in the day. It was in our best interest to put as many apps as possible on a server so we'd maximize ROI, makes everybody happy. Now, there's some pretty major unintended side effects of this world. We now have shared resources. Now, some people think this is great because, I don't have to duplicate that jar because it's just there. But the reality is this was more pain than it was worth. Because all it takes is one person to have a bug and my application goes down. I came into work one random Monday morning. One of my applications was down. I dug into it and discovered that, over the weekend, somebody had put a MIME type change in on those servers. And so 9 out of 10 apps went down. The only app that wasn't affected was the one that needed the MIME type change. Now, do not ask me how that didn't get caught in a lower region. I have no idea. But that's part of the pain of having these shared resources. Coordinating changes turns out to be really difficult. Every one of you at some point in your career has wanted to upgrade and been told, I'm sorry, you can't have that until everyone else is ready. I had one application, I wanted to get on the new strategic single sign-on solution, and so I talked to our infrastructure people. I said, okay, in order to do that, you've got to be in the first wave of server upgrades. So I got in the first wave of server upgrades, and then I went back a month or so later and said, hey, now that my servers are updated, can I have the new single sign-on solution? I was told, no, we're not making any changes to the server image until every server in the company has been upgraded. So I had to live on a tactical security solution, not for the few months that I had planned, but for closer to a year and a half. I've been involved in various currency projects in my career, and they were never a lot of fun. They were these 18-month slogs of freezes and testing and frustration. And that's frankly why a lot of organizations said currency's not worth it. That's somebody else's problem. Of course, we understand the impacts of not staying current. And that made me think of this Yoda quote. Fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering. I had no idea that for so much of my career I'd actually been practicing Yoda ops. But during this aspect, this time frame in software, we did this weird thing where we moved code from one instance of an app server to another instance of an app server. And we inevitably ran into this situation where, it worked in dev, but not in test, or it worked in test, but not in customer acceptance, or whatever regions you have. And you would just sort of beat your head against the table saying, why does this not work? Because the environments are supposed to be the same. That's what my infrastructure people told me. Now, the worst experience that I had personally took us 2 weeks to track down, and ultimately the difference between the servers was the order the patches had been applied. And this is literally where you start to think, what life choices have led me to this day? Is there a better way to make a living? Perhaps I can get into sales or marketing or something. There has to be another way. Now, things started to change, though. We started to turn servers into a commodity. Instead of using these proprietary things, we started using off-the-shelf hardware, off-the-shelf operating systems, and not surprisingly, prices came down. And we realized pretty quickly that that's not the constraining factor here anymore. We're the expensive part. And so as things like Heroku and AWS and App Engine and Cloud Foundry and Azure started becoming popular, we realized very quickly that shared servers are actually a liability. We can't treat them like pets. We have to treat them like cows. If you've ever been on a large-scale cattle operation, you realize they don't give cows names. They give them numbers. And no disrespect to number 15, but if number 15 gets sick, we put number 15 down and we get a new instance of number 15. And that's what we're starting to see now, is we're seeing more automation. We're seeing tools like Chef and Puppet and Bosch. We're seeing this notion of infrastructure as code. That's a huge step in the right direction, because as human beings, we're really bad at doing the same thing twice. If you don't believe me, try taking up golf as a hobby and let me know how that goes. Now that's fine for something you do for fun, but I can't have that in software. I need consistency. Human beings are terrible at repeating the same steps over and over and over again. We get bored, we skip steps, we try something different. The beauty of a script is it doesn't get bored. It will do the same thing every single time. So unsurprisingly, lead time started to drop. And at least some of this was a reaction to the public cloud providers. And what happened in a lot of organizations is a little shadow ops team would pop up. Parts of the company would go rogue. I've seen this a lot. Somebody figured out, I can get an instance up and running on AWS in a matter of seconds, and I only need to use my credit card. If I go ask my infrastructure people for the same thing, it takes weeks or months. And so that caused internal IT organizations to realize, hey, we can't be the long tent pole anymore. And so that's really fundamentally what we mean by IaaS. How do we provision these resources quickly? Sometimes on demand, as a self-service option. That's pretty powerful. Now, at least for part of my career, it was the same process as before, just faster. So how do we make this better? Well, a huge part of it's virtualization. The fact that we can put this abstraction over these physical compute resources, you put a hypervisor in there to manage all these VMs, and now we've got consistent coarse-grained components, which can still actually be useful today if you need ultimate flexibility. I need to open this port. I need to install these specific things. But of course, that means there's a lot more for you to manage. And we have to understand that in this entire cloud continuum of options, the more power we have, the more responsibility we have. We are now responsible for care and feeding of that instance. Is that something we want to be responsible for, or do we want to give that to somebody else? Now, again, there are instances where we need that even today. There are some specialized things where that's what we still need to do. But I would argue that should never be our first thought. It should always be our last resort. But that's fundamentally the bottom layer of the cloud. Now, on top of that, many of us are using containers, and for a lot of people that instinctively means Docker, although there are other container types out there. I think there's a bit of confusion around Docker. It is, the way I like to think about it, is a box. It's like a shipping container. If you think about the evolution of shipping, used to be a very manually intensive process. You'd need a whole bunch of people at both ports to carry all the stuff on the ship, and at the other port, you need a whole bunch of people to carry all the stuff off the ship. It took a long time. And then somebody had the brilliant idea to say, what if we standardize the size of these things? And you know what? We'll use a semi-trailer as our box size. And then now all we need is a crane operator to pick this thing up off the back of a semi-trailer, put it on the boat, rinse, repeat, and then it goes to the other side. Another crane picks it up, puts it on a semi, and off it goes. Works really well. Sped things up, made things cheaper. As long as it fits in the box, it ships. So when we think about Docker, it's the same idea. You put everything in the box you need to run. Code, libraries, executables, settings, et cetera, et cetera. Your code is fundamentally isolated from its runtime environment. So again, we've all had that experience of it worked in one region and not in another. And so we're not copying code from one instance to an app server to another instance of an app server running somewhere else. We're just putting everything we need inside the box. And that's what we're moving. Well, in a lot of cases, we're not moving anything. We're just changing a routing table. So it's the same basic concept as a virtual machine. It's just where do we virtualize at? Here it's at the OS level as opposed to the hardware level. Now, the trick with this, there's no free lunches. You are responsible for telling Docker what it needs. Out of the box, it's up to you. You have to configure all of that. Now, these Docker images are going to live in some kind of a registry that might be Docker Hub, probably not for something you're doing internally, mind you. This is a community-driven thing. Some of what you find on Docker Hub is not vetted or curated. Anyone can push anything, anyone can pull anything. I can attest to that. I've actually pushed stuff to Docker Hub. Now, it's not entirely the wild, wild west. There are verified publisher images. And so this is an opportunity for commercial entities and others to actually put out stuff like this is our official version. So these are things that have been approved by Docker, vetted by Docker, and many of those images actually have a support contract that comes along with them, which of course you have to pay for. Now you'll also find some images that are Docker certified, and there is a bit of overlap between certified and verified publisher. What that's telling us is, hey, these have passed certain tests, these images follow certain best practices, and they have been vulnerability scanned, although there can be some gaps in that, which I'll talk about here in a minute. There are also official images. These are things that Docker has said, this is blessed by us, we publish it. These are also, again, curated, documented, and tested. They follow best practices, and they've been vulnerability scanned. Except it turns out that that does have a little bit of a glitch in it if you mislabel something. I believe it's about 10 million instances of a mislabeled and vulnerable JDK have been downloaded. Perhaps you are using one now. You may or may not be aware of it. And the CTO for Azul had a fairly scathing comment about this, saying that millions of people on Docker are using mystery meat, incomplete and exposed builds, all because of, oops, we mislabeled something. So we have to be a little cautious about what we're using. We have to think through how would we now react to something like that? How would we make sure that when this is discovered, we can get all of our apps turned around so that they're not vulnerable to this issue? Now, at the end of the day, Docker Hub is just an instance of a registry. It's certainly not your only option. If you are doing this at scale in an enterprise organization, you almost assuredly have some kind of an internal registry. It could be Artifactory, it could be something else. You know, it's whatever makes you happy, but you're going to use something that sits inside your firewall. So what do we mean by image? It's not that complicated. It's just a template, a recipe. How do I build my container? Now, this almost always means I'm customizing some existing thing. So you have a parent image that acts as a starting point, and then I tweak from there. But again, you are fundamentally responsible for what goes in the box, and I'll say it again, with great power comes great responsibility. I've certainly seen instances where people have as many types of Docker images as they have applications. It's sort of the let 1,000 flowers bloom problem. So we have to be a little cautious with that. You need to have some kind of internal governance around that. And please stay current. It seems like every time I turn around, there's some new hack that exposed hundreds of millions of people's information. You know, now the Equifax one's getting kind of old, but it turns out people are still using that in production today. That is mind-boggling to me. And of course, that's not even the largest hack we've ever talked about. That's been pushed aside by Exactus. And of course, the Marriott chain said, ha ha, hold my latte. And they exposed 500 million people's information. And again, just because we have these verified images does not mean there can't be issues there. Now, I can't say Docker, I think legally, I can't say Docker without then mentioning Kubernetes. A lot of people are very excited about Kubernetes, sometimes referred to as K8s. This is another way of deploying, scaling, and managing containers. This comes out of work that has been largely done at Google. As you are probably aware, this is not their first rodeo. They've spent an awful lot of time managing containers at scale, so they have a lot of experience here. Now, Kubernetes has all of what you would expect, a lot of the same features that you would think of in any kind of scheduler orchestrator, self-healing, scaling, discovery, load balancing, automated rollouts, rollbacks, etc. And it all boils down to kubectl. Now, there's about 19 different ways of pronouncing that. Some people call it kubectl. Some people call it kubectl. Some people call it kubectl. That's usually what I refer to it as, although some people also like to call it kubectl with more of a t sound. I asked a good friend of mine once, I said, what do you pronounce it as? And he said, well, it depends on my mood. I'm like, really? I kind of thought there'd be like one way, but apparently there's not. So call it what you want. It's the it's the K8's command line interface. Now, I would argue most of us really shouldn't be spending much of any time at that level. That's really more of an operational thing, but that's really what we're talking about. And the beauty of Kubernetes is you describe your desired state. This is what I would like you to do, and then Kubernetes makes that happen for you. So insert your favorite Captain Picard reference here. Bunch of different abstractions that you'll hear about here: pod, service, volume, namespace, etc. Pod is just a fancy way of saying I house a container, one or more. This is where I get my storage, my unique IP, etc. Think of a pod as the fundamental unit of deployment in your world. It is, for most of us, an instance of an application. Now, that is often a Docker container, though it does not have to be. There are others that are supported. It's very common for this to be one container per pod, but occasionally you find these situations where these two are really, really tightly coupled to one another. And so it's easier if they can just talk directly to one another as opposed to having to essentially go all the way out and back in. So these are almost always referred to as a sidecar. Now today, everybody has a K8s option. There's GKE from Google. Amazon has a couple of different options here. So does Azure. We've got PKS. There is no shortage of options here. Now, we're already starting to see a little bit, I would say, of kind of that proverbial backlash here. You know, a lot of people are like, oh, I'm using pure Kubernetes. I don't need a platform. And then you realize you're actually building a platform on top of Kubernetes. And is that really what you want to be in the business of doing? Be very fascinated to see how this all kind of works out. You know, so Dan Woods has actually done a fair amount of work with it, and he keeps reminding people that, you know, it is upon which a thing we're supposed to build. It is not an end into its own. This is probably one of my favorite ways that people need to think about it. It is the secret sauce. It's not the meal. The meal is your application. Always has been, always will be. That's the part your customers care about. That's the part we need to focus on. All these things are, in large point, dial tones. Now, I saw this and I thought it was kind of funny. You know, we talk about it as this giant monolithic stateful application that makes it easier to manage monolithical stateful applications. State's hard, isn't it? A friend of mine had a great tweet about this. He said, if you don't think managing state is tricky, then why is it that rebooting solves 80% of our problems? He's absolutely right. Now, I hope we're getting here. I hope we're finally starting to understand that. Now, this is a constant I see in our industry. A new tool comes out, it gets popular, and we almost immediately start using it for things that it's not intended. Now, so the analogy I like to make here is, like, a sledgehammer is a fantastic tool if you're trying to do some demolition. If I'm trying to take down a wall, sledgehammer is really going to make that a pretty easy job. And so if what I'm trying to do is take down a wall and I use a sledgehammer and I'm like, wow, this worked really well, and I say the sledgehammer is such an amazing tool, I'm going to use it for everything, and then I go try to put up some trim and I use a sledgehammer, it's not going to end well. And then what typically happens in our industry is we blame the tool. We say, oh, sledgehammers are terrible. No, sledgehammers are great when you use them the way they're intended to be used for the problems that they're designed to handle. And so that's at least part of what we're seeing here. And unsurprisingly, we're already starting to see the, ooh, look, Kubernetes failure stories. This doesn't mean Kubernetes is bad. It likely means we used it in a situation it wasn't intended to be used, or we didn't know what we were doing and we hurt ourselves. You know, I don't know how to use like a circular saw. I know it's great if I need to cut some wood or something, but I'm not good at doing that. I'm likely to lose a finger. That doesn't mean circular saws are bad. So Kelsey's always got great tweets. This is one of my favorites. You know, so often in this industry, we try to make a tool solve all problems, and that's unfortunate, because then we almost always blame the tool. It's not the tool's fault if we used it inappropriately. And this, to me, is what we should be focusing on as developers. The thing you're building should be more exciting than the tools you use to build it, undoubtedly. Now, a lot of folks look at it and say, oh, it's so easy. It's very easy to get a Kubernetes cluster up and running. Every one of you can do that. I have no doubt about that. The hard part is managing that cluster. But it's fair to understand that this gives us another set of primitives that we can work with. Now, we can go a level above that, and we can actually rely on a platform that has some of this underneath it. This is yet another sort of layer of abstraction on top of IaaS. The goal of a platform is to allow developers to focus on applications and not on how that application is run. Now, the concepts are all the same. I'll speak about Cloud Foundry because that's the one I know best personally. But essentially what happens is you have a tool that sets up some VMs, and then you've got a controller that deploys and runs apps on top of those VMs. You've got a router that sits in front of it and knows where stuff is located, and then directs traffic as appropriate. As a developer, all you got to do is write the application. You don't have to worry about where the runtime comes from. The platform will give you that. You don't have to worry about the container, essentially. That's given to you. So if you think back, again, to what we had to do before, we were moving code from one instance to another, worked in dev, not in test, made many of us angry. You might even have flipped a table or two. My wife saw this slide and looked at me one day and said, "What is that?" I said, "It's table flip." She said, "What are you talking about?" I said, "See, table flip. Table's up in the air, arms up in the air, table flip." She shook her head and walked away and said, "You have a really weird job." I said, "You're not wrong." So we're not moving the code, we're moving the runtime. It's a coarser grained thing. So a whole class of problems disappears in these kind of environments. If it worked in dev, it's going to work in test because it is the exact same thing. In fact, we probably actually haven't moved anything at all. We just updated a route. So an entire class of issues just disappear. I don't need more variables in my life when it comes to software. It's hard enough. We don't need to make it more difficult. We need consistency. I'm sure many of you have at some point or another read through the 12 factors. Certainly one of the bits of the 12 factors that we have always wanted, regardless of the kind of apps that we were building, was dev prod parity. Never once did you say, "I'd really like prod to be radically different than dev because that makes my life more interesting." We need consistency. We need consistency because it shortens this code to prod lifecycle. That's a really good exercise to do in your own organization. Think about how long it takes to go from customer wants this change to that change is running in production. What is that measured in? Days, weeks, months, hours? To further simplify it, make it a really easy change. Make it like a CSS change. We want to go from this shade of blue to that shade of blue. How long does that take to get running in production? In a lot of organizations, that's still measured in weeks or months. And unfortunately, the pace of change does not allow us to get away with that anymore. So where does this runtime come from? In a lot of these environments, it's a build pack of some sort or another. You essentially say, "Hey, here, application platform, take my code and figure it out." And it looks through and says, "Oh, this looks like Java. I'll go ahead and grab the Java runtime." So it goes and grabs that build pack, shoves your app inside of it. That gets uploaded. The router or the controller looks around and says, "I have some capacity over here," drops it there, and away we go. Much like a Docker container, that build pack has everything you need to run that type of application. What this does for us is fundamentally moves the value line. At the end of the day, we want to make sure we're doing as much high-value work in our organizations as possible. Our customers do not bake us a cake for doing something that's below the value line. Upgrading servers is below the value line for them. Getting new functionality, fixing defects, helping them do their business better, that is why they want us around. We need to get out of the business of doing undifferentiated heavy lifting. And in a perfect world, we basically follow this haiku. We say, "Here is my source code, run it on the cloud for me, I do not care how." That's what we're striving for. Now, some people inevitably say, "But I need something unique. My application is a snowflake." You can absolutely customize build packs. I've had to do that in my past. Of course, the million-dollar question is that something that you should be doing? Now, there's 3 answers that work for every question in computer science. There's 42. There's another layer of indirection. That's one of my favorites as an architect. But this is the answer I rely on a lot these days. It depends. Now, some people get very mad at me when I say it depends. I never mean it depends as a way of ending the conversation. I mean it as a way of beginning the conversation. Let's talk about your environment. So in some cases, this is absolutely necessary, but you should always be a little skeptical. Because as soon as I build it, I own it. And do I really want to be in the business of care and feeding of this thing for the next N number of years? Because again, we need to think about currency. To me, that's the whole point of relying on these platforms. They get us out of the business of this undifferentiated heavy lifting. We have to ask ourselves, what is it that our customers care about? It is not the runtime. It really isn't. Now, it's important, don't get me wrong, but that's not what they value. That's dial tone for them. Again, no customer has ever baked you a cake for revving an OS version, as necessary as that is for us to do. What gets our customers excited is features. That's what they want. That's what they need. That's why they're paying us. Platforms free us to think about that and focus our time on solving their business problems, not on these underlying plumbing issues. Now, there's a bunch of different options here. Cloud Foundry, Heroku, all the public providers seemingly have something similar, but it's a very popular place to be for good reasons. That, of course, brings us to serverless. Because as you expect in our industry, things always change. There's always something new. Surprised we haven't already invented the thing that's after serverless. We've gone from IaaS to CaaS to PaaS, and now a lot of people are very excited about functions, and of course, everything is as a service today. I actually had somebody come up to me last year and say, I'm going to refactor my application as a series of functions. I thought, well, it's possible that you have an application that truly is nothing other than a set of functions. It's highly unlikely that everything your application's actually doing is a set of functions. There's undoubtedly something in your environment that would work really well as a function. It's probably not the whole thing. So a lot of people look at this and they say, great, I don't even need servers anymore. This is fantastic. And you might get a little grumpy and say, I just refactored to cloud-native microservices, and now you're telling me I have to replace all that. I don't want to throw away my code. That makes me kind of grumpy. Again, maybe you flip some tables. Please don't throw away that code just yet. I don't know what it says about me, but I actually have table flip as a keyboard expansion on my phone. I don't know if that's a bad sign or not, but I use it enough that I made a keyboard expansion for it. Now, there's a lot of confusion around FaaS versus serverless. I think it's fair to say FaaS is a subset of serverless. A lot of people use those terms interchangeably. And as I've already said a couple times, there are still servers. I'm sorry, bad naming. We're just further away from them than we were before. So in a serverless environment, we are not responsible for provisioning the servers, updating the servers, scaling the services, et cetera. That's somebody else's problem. Now, this undoubtedly suffers from the shiny new thing curse. I've seen an awful lot of folks in our industry act like dogs chasing squirrels. Ooh, something new to play with. Ooh, blockchain. Oh, machine learning. We just chase after it because, quite frankly, we'd like to put it on our resume. A lot of us practice resume-driven design. I'm guilty of it. And so there's things that come along with that, unfortunately. And I've seen a lot of the lemming effect already start to appear here. There's some really good white papers that have been written. There's been some really good success cases. And so people read that and say, well, because company X was successful, company X saved X amount of dollars, ergo, we must use it. That's not necessarily the case for you, though. You might not have the same constraints. You might not have the same pressures. You might not have the same assumptions. It might not work as well for you. It might not work at all. It might work better. You have to look at your own circumstances. I was talking to somebody last week about this, and he was saying that he's getting a lot of pressure in his company to move to the cloud, and he's saying, but we have all these constraints on us. We have this response time that's really hard to get in the public cloud providers, and so what do I do about this? And one of the bits of advice I actually gave him was see if you can give them a win. Is there something you can move into the cloud so that this senior manager who is giving you all this pressure can declare victory and stick a flag in the ground saying we moved to the cloud, even if it's just one function that we moved there, just one little chunk of code. But it's important to understand your own circumstances. Now, there are some very, very good reasons to utilize this approach. Sometimes it's specifically because of a platform we're already deployed on. Maybe we've got a bunch of data sitting with one of the providers. Maybe we've got a bunch of stuff sitting in Amazon S3. We'd like to do something with that. Maybe we want to tap into a service that's being given to us or offered by one of these providers. Maybe we want to utilize cloud machine learning from Google. But it's not just a new way to cloud. We get some very serious efficiency gains here. Now, some of it starts at our level, at the developer level. We are further up the abstraction hierarchy here. I can focus on solving a specific business problem, not all the infrastructure that goes behind it. And these should be small. These should not be ginormous. I always like to ask people, do you know what operating system you're running on? You probably know the operating system, but do you know which version? Do you know exactly which patch level you're on? And there's inevitably one or two people who do. But I'd ask you a more probing question, which is, do you care? Where do you want to spend your time and effort? Where do your customers want you spending your time and effort? What's the value line for you? Again, we want to get out of this business of undifferentiated heavy lifting. Now, my boss actually has an interesting view on this. I love this slide. Good job configuring servers this year, said no CEO ever. And he's absolutely right. It's important work, don't get me wrong. It has to be done. But that's not what makes our customers happy. That's not what gets them excited about the stuff we're doing for them. We need to focus on solving business problems, not these underlying plumbing issues. We get some very serious resource efficiencies, because if my function has not been called recently, I can terminate the container. I pay nothing when there's no container there. Request comes in, awesome, we spring a new existence into existence. So it might look a little something like this. A friend of mine actually built a little sample app that relies on data about earthquakes. And so most of the time they're not happening or they're not that interesting, and so you're just kind of sitting there waiting, and then oops, something happened, the earth is moving, which is kind of terrifying, at least it is to me. I don't live in a particularly geologically active area, and so like every time I'm in California, I'm always thinking about that. Like an earthquake has got to be a really scary thing to be in the middle of. I guess you get used to it. So earthquake happens, notification service springs into existence, address service springs into existence, and now we can start sending out notifications to people about, hey, guess what, somewhere near you there was an earthquake. Now, maybe it turns out that we're getting an awful lot of requests for address information, and so we can spin up additional instances of that. And then as that pressure eases, we can go ahead and drop that back down to a smaller number of functions that are handling that. And then once things quiet up again, no problem, those containers go away. And again, we're not paying anything at that point. Now, it's important to understand that just because the first million or two are quote-unquote free, we need to be very aware of the fact that additional fees may apply. So anytime you're doing data transfer, anytime I'm leveraging other services, I'm paying something. So no, functions are not free. Once you get past that initial free tier, you are charged some interesting fractional amount. That's based on the number of requests, the run duration, and how many resources you allocated for that. It can be very difficult to determine just how much that's going to cost you. Now, I'll give you a real-world example. A friend of mine, someone at her office was playing around with a function, and they left it running and forgot about it. At the end of the month, they got a $100,000 cloud bill for that one function. I'm fairly confident that was a bit of a uncomfortable conversation with management to talk about the $100,000 fee you racked up on a proof of concept function sitting in the lab. Oops. Now that said, for certain workloads, it doesn't get any cheaper than this, but you have to run the math. You have to get a little spreadsheet out, best case, worst case, what if it's double that, and understand what your bounds might be. And then you probably want to have some kind of governor in place that says, hey, if I see this much happening, I should probably at least alert somebody to go in and clean it up. We get some very serious operational efficiencies. Some people refer to this as serverless ops. In fact, my friend and colleague Paul tweeted this out and says, what idiot called it serverless and not DevOpsless? I mean, in fairness, serverless rolls off the tongue better, I think is what it boils down to. Now, again, that doesn't mean there's no work here. It's just less for us to worry about. The important step for us is we should be relying on a platform. Let the platform handle this for us. Now, there's any number of use cases that fit really well in this space. If you've got rapidly evolving business requirements and they're changing constantly, this can be an easier way to handle that. When you're dealing with stateless workloads, this is a pretty good option. If you've got infrequent or sporadic requests, my favorite go-to example is every application you've dealt with that has some kind of account functionality to it. When you go in and make a change, you update your phone number, your address, your password, some amount of time later, you get a notification about that fact. Might be a text message, might be an email, might be both, who knows. That notification process to me is a perfect example of where a function becomes very, very useful. Because I don't know how I would put any kind of prediction around how often somebody is updating their account information. It probably doesn't happen on any kind of regular cadence. So to me, that's a very good example of these sort of variable scaling needs that we have. I've had some people argue with me, I don't need to use these things because I can absolutely predict my traffic. I find that hard to believe. I mean, yes, some things are very predictable. I spent a lot of my career, in financial services where you knew there were certain dates that were going to be a big deal and you planned around those, but that doesn't work for everything for sure. Asynchronous workloads work very nicely here. Anything I can parallelize. You see a lot of this in the IoT space, machine learning, batch processing. Almost all the conversational UIs at the end of the day are relying on serverless in some way, shape, or form. There's some interesting things with CI/CD, chat integration, et cetera. I read about one company that had created a little function that essentially watched Stack Overflow, and when people mentioned their company name, it sent an alert to the development staff to go look at those questions to see if there was something they could do to help. An awful lot of the sort of website back-end stuff that we do fits well into this particular set of tools. Event processing, monitoring, notifications, scanning. It's a really, really useful thing to have in the toolkit. It is not, in fact, the answer to every single workload, but you already knew that. Now, one of the things you hear people talk about in the serverless space is cold startup. They say, oh God, I can't use serverless, or particularly I can't use Java because Java is slow. Well, I'll say a couple things. First of all, if you think Java is slow, go Google for Dave Sire and watch almost anything that he's talked about in the last year and a half. It doesn't have to be slow. It can be ridiculously fast. The reality is, if you are using serverless in a situation where latency matters, you've made a bad architectural choice. So if I'm using serverless to do batch processing, if the first request takes 3 seconds to warm up that container, and every subsequent request takes 300 milliseconds, who cares? Now, if I'm using this in a situation where that latency is going to be felt by an end user, and 1 out of 10 or 20 customers is going to have this really bad experience because I have to warm up all these containers, I made a bad choice as an architect on that project. I used the wrong tool. I used the wrong abstraction. I should try again. So if it's latency sensitive, this is probably not our best choice. Don't get caught up in debates over one language is faster than another. That's not really the relevant part of this. I saw one tweet where somebody at a conference said the best thing you can do is have one function that constantly pokes your other function to make sure it never goes out, never gets shut down, and then that avoids the cold container startup problem. Except you're paying for resources you're not using, and that just doesn't seem like, again, you've probably chosen the wrong abstraction if you feel the need to constantly poke your function to make sure it doesn't go out. Now that leads us to this question. What should you choose? You all probably know what I'm going to say next. It depends. Depends on your situation, depends on the workload, depends on what you're trying to do, depends on what's the right answer for you. There is no one answer that works for all of them, I'm sorry. In fact, the real answer here is it's an and, not or situation. Different workloads fit in different buckets. The challenge for us, the complication for us, where we earn our paycheck, is figuring out what's the right spot for this particular workload. Understanding, of course, that there are trade-offs here. There are pluses and minuses. You know, I made my grad students install Nginx on an app instance on one of the cloud providers. As you know, just spin up a compute instance and install it, because I wanted them to feel the pain of doing that, so they would appreciate what happens when you don't have to do that. Right? So we have to understand the trade-offs here, and that shouldn't come as a surprise to any of you. Now, it's fair to look at the fact that we have a lot more moving parts now. And as Sam pointed out, these all need to be patched. Haven't we actually made things much, much worse? And he's not wrong. Sam's very smart. And that prompted a response from Josh Long, who said, well, yeah, that's why we have these platforms like Cloud Foundry. That's why we have the public cloud providers. So that all you have to focus on is your app. Let other people deal with these underlying plumbing issues. Somebody that has a vested interest in doing it well. It's important to understand that these things are just tools, and they all layer on top of each other. So we still have IaaS. IaaS is fundamentally what's giving us that compute instance. And we might use containers on top of that, in which case I'm responsible for bringing a container to the party, and that environment is going to give me scheduling, networking, routing, metrics, etc. I can go a step up from that, and I can rely on a platform. The platform is going to give me that container, and all I have to worry about is the application. And that container environment, or that platform environment, is going to give me the images, networking, metrics, a marketplace, quotas, etc. I can go a step up from that, and I can use serverless. Again, the container is provided for me. You can even argue the application is essentially provided for me, because all I have to do is write a function, 5, 10, 20 lines of code. And then that function environment is responsible for execution, scaling, binding, etc. The big difference here fundamentally is what am I responsible for versus what the tool gives me. At the end of the day, these are just different levels of abstraction. These are just different tools I can bring to the party to solve these problems. The challenge for me is figuring out what fits in which bucket. That's all we're really talking about here. Different levels of abstraction. Now there's another way of visualizing this, sort of this layer cake idea. There's still hardware. You might own it, someone else might own it. You can use IaaS to generate that. Give me a slice of that, please. I can use a container to run my code on top of that. I can use a platform if I don't want to mess with that. I can use serverless if I want to go even higher up the hierarchy. The further down I go, the more flexibility I have. If I'm using raw hardware, I can open up any port I want. I can install anything I want. I'm free to do anything I want. If I go higher up that hierarchy and I go to serverless, I'm not free to use any language I might ever envision. I'm constrained by the languages that are given to me. I can't use unlimited resources. I'm constrained by how much resource I can use for that particular invocation. I can't run forever. Again, there's a time limit on all of those. The moral of the story is we're trying to get as much as we can, as high up that hierarchy as we can, understanding that not everything fits in every bucket. And of course, with greater flexibility also comes greater responsibility. It can be harder to develop. We become more responsible for patching things. It's probably in our best interest to just focus on pushing apps. I saw this quote and I thought it was pretty meaningful because there is a lot of sort of belief in containerization. And I like this sort of phrasing that, you had one problem before, which is run an app. If you're going down the containerization route, you now have to run a container that runs an app, and then you have to maintain that container. We just have to understand what that means for us. What is our responsibility in that environment? We need to think about the operational efficiency. We need to ask ourselves, how many operators do we want maintaining these environments? And again, where do we want to spend those resources? Would our customers be happier if some of that money and resource was spent on developing applications? Probably. We need to understand that trade-off between flexibility and standardization. I also like to remind people that guardrails aren't shackles. They're there to protect you. And you need to ask yourself, how do you want to allocate your resources? Now, it's up to you to figure out what's the right option for the problem in front of you today. But again, I would urge you to push as many things as high up that hierarchy as possible. Now, there's a lot of FUD here. There's no getting around it. There's a lot of I'm chasing the new hotness. Please be strategic. And understand that hope is not, in fact, a strategy. The nicest thing I can say about hope is it's what rebellions are built on. You need to be deliberate. You need to understand the benefits and the limitations and understand that these things are just tools. That's it. The analogy that I've been using is construction. So my wife and I finished our basement recently, by which I mean we wrote checks to people to do it because I'm a software person, not a hardware person. I wanted it to be done in my lifetime, and I wanted it to be, nice. So as someone who's not an expert on this, I have one hammer, and that's more than sufficient for me to screw up any project around the house. The folks that came to do the work didn't just have one hammer. They had a truck full of hammers, and they knew when to use which one. It's the same for us. If I show up and work with you and I say, this is the one abstraction I use, everything has to be in this, period, you should ask me to leave. Because the moral of the story is not everything fits in every one of these abstractions. We have to know when to use which tool. That's the difference between someone who knows what they're doing and someone who's, hey, I found a new hammer, someone please bring me a problem. Please do the right thing. I wish you luck. I'll be milling about here for a bit if you have any questions, but thank you so much for your time and attention. I genuinely appreciate it. Cheers.